Hey math kids, today we're going to talk about limits. And so the concept of a limit is when we get infinitely close to something. And so when we were talking about the explanation on the last video of instantaneous rate of change, we're looking at the limit at that point to get a derivative out of it. And we'll eventually get into what is a derivative. Okay, so what we're going to do, I'm just going to jump into some examples because I think that's the best way to understand it. So the limit as x approaches 2 of x squared. And here, I'm going to write out all these limits. And we also have the limit as x approaches 3 of x squared minus 9 over x minus 3. Okay, so we're going to do this first one right here. So if you can just plug in the limit, that's all you have to do. If it doesn't break any rules like division by 0 or anything like that, you just plug it in. So I just do 2 squared, we get 4, and so the limit as x approaches 2 of x squared is equal to 4. Okay, now we're going to look at this one. Now the problem is we can't plug it in right away because if we plug in 0, we get division by 0 because there's an x on the bottom. So what we need to do is we need to factor the top, take an x out, and we're left with that. These x's cancel, and so the limit as x approaches 0 of x plus 3. Now we can just plug in the 0, and we end up with 3. Okay, similar idea here. If we plug in a 3, we'll get 3 minus 3 on the bottom, so we'll get a 0 on the bottom. We can't have that. So if we factor the top using difference of squares, we square root, plus minus. So we get x plus 3, x minus 3 over x minus 3. X minus 3 cancels. So now we look at the limit as x approaches 3 of x plus 3. We plug in our 3. 3 plus 3 is 6. So that's our limit. Okay. Now we're going to move on to another example. Now we have f of x is equal to 2 minus x, 1 plus x. So it says discuss the behavior of f of x near its asymptotes and hence deduce their equation. Okay. So what we're going to do is probably the best thing to do on this one is to graph it so you can see a visual. So let's go. Well, let's see. I'll do it on the graphing calculator, I guess. So you can practice getting that done. Okay, so we want to graph, and so we're going to say 2 minus x divided by 1, oops, need a parenthesis, 1 plus x. And we graph that. Okay, we see we have a vertical asymptote and we also have a horizontal asymptote there. So based on the equation, we know that our vertical asymptote is going to be at -1 because that creates division by 0. Okay, and so we have that, and then we have a vertical asymptote at -1. Now, to find the exact placement of the horizontal asymptote, it's just going to be -1 because we have the same power on top and bottom, and it's just the ratio of the leading coefficients. So we have -1/1, and so we end up with y equals -1 for a horizontal asymptote. Okay. Now, if we look back, we see that, and so that goes down, that goes up, and so they kind of follow. Let's see. So they kind of follow this pattern, and then follow this pattern. And now we're going to talk about the limits at the behavior at different points. So what we're going to do is as x approaches -1 from the negative side. So that's kind of confusing. So we're on the negative side of -1, so we're like over here. And as we approach -1 from this side, we go down. So we're going to say f of x approaches -infinity. Okay, now we're going to approach that asymptote from the other side. So as x approaches -1 from the positive side, what does f of x do? Well, f of x approaches positive infinity. Okay, now now we're going to look at the ends. So as we approach -infinity, so as we're going right here, so as x approaches -infinity, what does f of x do? Well, f of x gets closer and closer to this -1 value, which is and it's on the negative side. So this time the negative is down. So it approaches -1 from the negative side. So this is referring to the white horizontal asymptote. Okay, now x approaches positive infinity, so now we're talking about this piece. What does f of x do? Well, f of x approaches this asymptote, which is at -1, but it's on top of it, and so it's approaching from the positive side. Okay? Now, part B says, if they exist, state the values of these limits. So I'm going to write these down. So the limit as x approaches -infinity of f of x, and the limit as x approaches infinity of f of x. Okay? Now, we've already actually found the answer to this. Okay. I don't know what's going on. It doesn't want me to put that red. Okay, cool. So, if we're approaching infinity, we are approaching -1, and then if we are approaching -infinity, we're also approaching -1. Okay, so the limits are both just -1. So if we're talking about a limit, we don't really care about what side we're coming from right now, but when we're talking about the behavior, then we do. So this is listed as the behavior. These are listed as just the limits. Even though they give us very similar answers, they're slightly different in the way that we talk about them. Okay, so we just have a couple more. So we're going to say the limit as x approaches -infinity of 3 minus e to the -x. And then we're also going to look at the limit as x approaches infinity of 3 minus e to the negative x. So the only difference in these two statements, this is negative infinity, this is positive infinity. Okay, so once again, I think we should look at a graph. So click on this. Let's see, go to the equals, and we got 3 minus e to the negative x. So we graph that. Okay, we see there's a horizontal asymptote. From the equation, we know that's going to be 3 because it's just shifting it up 3. It's normally at 0. And so if we just sketch this, you can see we have something like this with a horizontal asymptote at 3. Okay, so if we're looking at the first one, the one where we're approaching negative infinity. So as x approaches negative infinity, we go down, and we go all the way down to negative infinity. And so what that means for the limit is that the limit does not exist. Okay? So you guys can triumph and quote Mean Girls over and over and over. The limit does not exist, the limit does not exist, the limit does not exist, okay? Because that's what happens when we diverge to negative infinity or diverge to positive infinity. So since we went to negative infinity as we went to the left, we went down forever, there is no limit, and so it does not exist. Now, if we go to the right, our y value gets closer and closer to 3. And so that is the answer for the limit. Okay? So we want to converge to a number, and then we call that the limit. So if you need additional help, come to Math Lab. Until then, calculator.